Okay guys, so what we're going to be looking at is something called the rational root theorem. What this rational root theorem does is it tells us what our possible solutions are for any quadratic or any polynomial, in fact, function. Let's look back at our warm-ups. On our warm-ups, these solutions were 2 and -3. If you had asked me what are the possible solutions, I would have looked at this number and I would have said, well, it could be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Can you see what I'm doing to tell you what the possible solutions are? I'm just looking at this last number. If you asked me for the possible solutions to this, I would say they were plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. See the pattern there, what I'm looking at? I'm just looking at what can 10 be divided by. 10 can be divided by 1, 2, 5, and 10. These are going to be my possible solutions. Let's go to this one though. For this one, it gets a little tougher. I would first look at this number here. 3 can be divided by plus or minus 1 and plus or minus 3. This one though has a coefficient. So I would have to say, what can 2 be divided by? Well, it can be divided by plus or minus 1 and plus or minus 2. So here are all the possible roots, and we call them rational because they're fractional. The possible rational roots here are going to be 1 over 1, plus or minus 1, 1 over 2, so plus or minus 1/2, 3 over 1, so plus or minus 3, and 3 over 2, so plus or minus 3/2. These are all the possible roots, all the possible zeros that I could get right here. Okay? So, looking back here now, what we're always going to do first is we're going to find P. P is always going to be the factors of the constant term. So P, we're going to look right here at the end. Whatever the factors are, that's what we're going to find. Q is always going to equal the factors of the lead coefficient. And we just divide them, just like I showed you. Okay? It's exactly what's written here. So I want you to write down this problem. Find the possible rational roots for f of x equals 2x to the third plus 3x squared minus 11x minus 6. Remember, it kind of goes in the opposite order of what you would think. A lot of people think we should find the factors of this first. That's not true. We always look at the back, the very last constant term. And I'm going to look at the factors of that number. So, Abigail, can you tell me the factors of 6? Good. Q is always going to be the factors of the first, the leading coefficient. Becky, can you tell me the factors there? Good. So to find my possible rational roots, I have to look at every combination. So we're just going to abbreviate this. P, R, R. Our possible rational roots. Well, I can do 1 over 1, plus or minus 1. I can do 2 over 1, plus or minus 2. I can do 3 over 1, plus or minus 3. And I can do 6 over 1, plus or minus 6. So I've used the 1 every way I can, so I'm done with that. My other possible rational roots are 1 over 2. So plus or minus 1/2. 2 over 2. Did I already use 2 over 2 though? What's 2 over 2? Just 1, I've already got it. Not going to write it again. 3 over 2, so plus or minus 3/2. Finally, 6 over 2. That would be 3. I already wrote it. So these right here would be the only possible rational roots to this problem. So we're going to keep going now. So now we want to find the zeros for the example. To find the zeros, that means I'm going to take this function and I'm going to set it equal to 0 and solve it. I have 4 terms, so I would be thinking, can I use factoring by grouping? Well, think ahead though. If I group it 2 and 2, is it going to work to do factoring by grouping? It's not, is it? Here are all my possible solutions. I could go through and I could test 1, test -1, test 2, test -2, until I found all the things that worked for this. It takes too long though. So we're going to use our graphing calculator to help us. So go to y equals, and let's type in 2x to the third plus 3x squared minus 11x minus 6. We can do a zoom 6. Here's the way it looks. How many zeros do we see here? Is that right? Is that how many we should see? No. Okay. I want to find all 3 of those, because it now asks me to find all the zeros. Well, I'm just going to use my table, and I'm just going to use my table to find one of the zeros. See how it immediately tells me one of the zeros is -3? Does everybody see -3 on theirs? So I now know that -3 is one of my zeros. I can go ahead and write it down here. That's one of my answers. I have to find 3 total. So now I'm going to use synthetic division. I'm going to write out the rest of this. I've got 2, 3, -11, -6. I'm going to bring this down. That's -6. I'm going to add. That's 9. I'm going to add. That's 6. I'm going to add. So I'm left with this. And I got a 0, so I knew for sure. I double checked. -3 definitely is a 0. It caused us to give 0. So now I'm going to have 2x squared minus 3x minus 2. If I factor this and solve it, this is going to tell me my other zeros. So go ahead and factor it. 2x and x. I want to get a -3 in the middle. I'll never put a 2 and a 2 in the same parentheses, because that would have meant there would have been a GCF. So it's going to have to be the 2 here, the 1 here. Where's the negative going to go? In front of the 1 or in front of the 2? In front of the 2, right? So this is the way it factors. So what's going to make this factor equal 0? -1/2, good. And what's going to make this factor equal 0? 2. And so those are going to be our 3 zeros right there. I could check those. Watch what I can do. Suppose I'm not sure about that -1/2. I can do second trace, calculate a value when x equals -1/2. What should I get there? Everybody should know. What should I get? 0. And I do. I'm going to check my other one. Second, calculate a value when x equals 2. I better get 0, and I did. So those are going to be the 3 zeros. Okay? But this is where it kind of all started. I knew that any answer I got had to be one of these, 1, 2, 3, 4, 5, one of these 12 had to be our solution. See how we got -1/2? That's in there. +2, -3, all of them are in there. So why do we really take the time to know this? Well, it helps us with questions like this on the back, on page 100. So flip over to page 100 and answer number 11. According to the rational root theorem, which is not a possible solution of the equation shown? Take a couple minutes, figure it out. Which one would not be a possible solution? Charlie? D, and how'd you get that? Good. And so it can't be 2 over 1, can it? It could be 1/2, but not 2. All right, very good. Okay, so now let's go down to number 12. This one's a little more challenging. It says to find all the zeros of this function. We could write out all of the possibilities, but that's not really going to help us. I mean, then we'd have to go through and check them all. Not great. So we want to see if we can factor. So here's kind of our process when we're trying to find real zeros. First, we try to factor. And if we can't factor, then we're going to use our graphing calculator to find one. To find 1 0. So I can't factor this. There's no grouping that's going to work or anything. So we're just going to have to type it in. So go to your calculator, type that whole thing in. So I'm going to do a zoom 6, just kind of look at it. I should have 4 zeros. Sometimes our zeros don't even show up on here though, because they could be complex zeros that we don't see. We haven't gotten into that yet, but that can happen. So now I'm going to look at my table, and I just want to find a 0. There, I don't even have to move. Do you guys see the same thing? Everybody see a 0? Maybe yours are down here further. You could keep scrolling and scrolling until you found a 0, but you got to find at least one. There we go. We've got one at -4. So I know -4 is one of my zeros. I like to keep a list down at the bottom. I know one's -4. How many total am I going to have again? 4. Okay? So I'm going to put -4 goes in the box. I don't have to change the sign. A lot of times people think, don't you have to change that? When do I change it? Not if it's a 0, but if it's a factor. If it had been a factor, then I have to change it, but not for this. So it's going to be 3, 11, -40. Just putting our coefficients. Okay, so we're going to drop this down. Guys, when you're multiplying here, instead of doing 36 times 4, do 36 times 2 is 72, and then times 2 again. 72 times 2 is 144. That's a lot easier than multiplying by 4. Okay, so this is what I'm left with. So since it was to the 4th at the first part, and now I can just do factoring by grouping. The way that I know grouping is going to work is I'm kind of thinking ahead. Looks like it's going to work, so let's try it. Baxter, what can I factor out of the first two?
X squared.
What would I be left with?
You would be left with 3x minus 1.
Right. Maya? What can I factor out of the next two? Good job. -12. So negative 36x divided by negative 12 is positive 3x. And positive 12 divided by negative 12 is minus 1. Hi, what can I take out now?
You put them into x squared minus 12 times 3x minus 1.
Right, so I've got x squared minus 12 times 3x minus 1 has to equal 0. This one I can solve pretty easily. What's this one going to be, everybody? What's the 0? 1/3. So now I've got 2. I've got to find 2 more. Well, now I'm going to have to set this one equal to 0. I can't really factor it anymore, so I'm going to just do this. I'm going to solve it instead. I get this. I take the square root of both sides. What's the square root of 12? 2 radical 3, and what do I have to put in front of it? Plus or minus. So I'm going to have positive 2 radical 3 and negative 2 radical 3. Guys, those are always going to happen like that too. For example, if 5 radical 2 is a 0, negative 5 radical 2 has to also be a 0. If 8 radical 7 is a 0, so is negative 8 radical 7. They have to occur that way. And that's what we're going to look at again on page 98. Flip back over to page 98. The irrational conjugate theorem. So this says, let f be a polynomial function with rational, that just means fractional or whole number coefficients, and let a and b be rational numbers, such that radical b is irrational. If a plus radical b is a 0 of the function, then a minus radical b is also a 0 of the function. All it's saying is this. 4 plus radical 3 is a solution. Using this, what does the other solution have to be? 4 minus radical 3. If 2 plus radical 7 is a solution, what's the other one? All right, let's do one a little more challenging. Negative 2 minus 4 radical 5. What's the other one that would go with that? Very good. So these are called conjugates, and they always have to occur this way. Both of these have to be solutions. If one of these is a solution, the other one must be a solution. All right, now go back over again to page 100. Write a polynomial function of least degree that has rational coefficients, a leading coefficient of 1, and the zeros are negative 5 and 4 plus radical 2. So if negative 5 is the 0, what would it have been as a factor? Mitchell, do you know that if negative 5 is the 0, what would it have had to have been as a factor? There we go. You just have to change the sign. If negative 5 is the 0, then the factor had to have been x minus negative 5. And what does that simplify to? X plus 5. So x plus 5 has to be one of our factors. Now we have to find the other factor. Now, if 4 plus radical 2 is a solution, what else has to be a solution, guys, based on what we just said? 4 minus radical 2. So I have one of my factors, but I need to know what's the factor, the quadratic factor, that would give me these two solutions. Do you remember what we did earlier? How to do that? Did you guys write down that formula from the warm-ups? Did you remember it? What do I do first? What do I find for these two? Find the sum. What is the sum? Add them. 4 plus 8. The product. That means multiply them. I have to FOIL it. The first the outers, the inners, the last, distributing that through. So the first times the first is 16. The outers gives us negative 4 radical 2. The inners is a positive 4 radical 2. And then what's radical 2 times radical 2? 2 minus 2. What is that product then? 14, good. So can somebody tell me then what the factor would have been? The factor means with an X. Anybody know? Joey? Say it again? No, because we have to use the sum and the product. Abigail? There you go. Remember that formula we used? Yep. So here's one of our factors, here's one of our factors. We had 1, 2, 3 solutions. So that's why we have really 1, and this is 2 solutions together because it's a quadratic. So if I have to get a polynomial function, I've got to multiply all of this out. So let's go ahead and do that. So the name of our polynomial function is supposed to be g, so we'll call this g. So x times x squared is x to the third. X times negative 8x is negative 8x squared. X times 14 is 14x. Keep going. 5 times 40, that's going to be 50, and 20, 70. And now just combine your like terms. Now, if I were taking a quiz or something, I would double check this, because I went through that pretty quickly. What I would do to check it is I would just put this into my calculator. And I want to make sure that 5 is a 0. It's supposed to be. If I look at my table, I better see that 5 is a 0. Oh my goodness. What did I do wrong? Let's see. X to the third minus 3x squared minus 26x plus 70. Did anyone get a different answer than I got for this? 0 is what? Yeah, but we adjusted to, oh, thank you. Yeah, on the table, I'm looking for negative 5, not positive 5. So let's look back at that. Yeah, there we go. I was just looking somewhere else. So negative 5, we have our 0 right there. So it works, right? Okay. So, number 14, let's try this one. What are the real zeros of the function? Look at the function, find out where it equals 0. What are the x's that cause it to equal 0? Caroline, what are they? You have the zeros. What are the zeros? Right. Negative 6 and 0. Look at the next one. Write an equation of the cubic function in factored form. That's good. I like to see the word factored because that means we don't have to multiply it all out. If we see a polynomial function, that means we did have to multiply it all out. So factor is a little bit easier. Now, it's supposed to be a cubic function. What degree is that then? Degree of 3, right? So y equals, and that means I have to have 3 factors. I only have 2 factors. Anybody know why I only have 2, Michaela? Correct. Exactly. So right here, this is going to be a solution twice. 2 times, that's a solution. So if 0 is my answer, is my 0, what was it as a factor? Just x. But it's a solution 2 times, so what do I have to put? X squared. Negative 6 is a 0. How do I write that as a factor? x plus 6. And then, just to double check, I would just type it in, x squared times x plus 6. And it should look exactly the same as that, and it does. It's just that their window's going from like -20 up to 40, about. So there we go. See how nice? We got it. Any questions? Yep, Troy. Well, that's a very good question. If that had happened, we wouldn't really have quite enough information to even do the problem. Because if it's up higher, we would have to have 3 factors, and we would only have one of the factors, this one, and the other 2 that we would really have had would be called imaginary or complex, and we're going to get into those later, that type. But yeah, that's a very good point, that if this had been shifted up, we would have still had the 1, 0, but we wouldn't have had that one, so it would have changed things a little bit. That's a really nice point to make, though. Can you guys think of any equation that would give me 2 imaginary solutions? Think of an equation that would give me 2 imaginary solutions. A quadratic equation would give me 2 imaginaries. Come on, guys, I know you can do this. Go ahead, Natalia. X squared in the parentheses, is that what you said? X squared times x plus something? Okay, I mean it could, but it really doesn't even need to be that complicated. I just want some quadratic equation. So this would now turn it into a quartic because we'd have x to the 4th. Yeah, go ahead. You got it, yeah. That gives me 2 complex solutions, or 2 imaginary, rather, solutions. Here's the reason why. We take this over, we take the square root. What do we do when we have a negative end of the radical? I, right? So this would be actually x equals plus or minus 2I radical 3. What if it had been this, x squared plus 9? Think about it. What are those 2 solutions going to be? Michaela? There you go. It's kind of cool. This can actually be factored into x plus 3I times x minus 3I. Eventually we'll be going to things like that. So Charlie, your problem led us to all this stuff, which is where we're going to be going later on, but he's correct. If that got shifted up, we're going to have imaginary solution in addition to the real one of that. Okay guys, back here just real quick one more time. Remember what you're going to do on this kind of problem. You're going to try to factor. If you can't factor, then you're going to use your graphing calculator to find 1, 0. What do we do after that? Use what? What did we do with that 0 we found? Used what method? Synthetic division. And then you're just going to go back through it again. You're going to just try to factor what's left. If you can't factor it, you could use your graphing calculator to find 1, 0, but you should be able to factor it at that point. Okay? So your assignment is on your assignment sheet. You still have some time. I'd like you to get started on that.